All right. This is chapter 6 of the Cybersecurity Essentials 1.1. We're looking at the five nines concepts. We're looking at high availability, measures to improve availability, incident response, and disaster recovery. High availability. So, what is the five nines? So, five nines means that the system and services are available for 99.999% of the time. So, it also means that both planned and unplanned downtime is less than 5.26 minutes, which is 5 minutes and 26 seconds per year. So, high availability refers to a system or component that is continuously operational for a given length of time. So, to help ensure high availability, eliminates single points of failure and designed for reliability, detect failures as they occur, and also set up preventive measures for um, failure points. So environments that require five nines. So although the cost of sustaining high availability may be too costly for some industries, several environments require the five nines. So the financial industry needs to maintain high availability, right, for continuous trading, compliance, and customer trust. Then also healthcare facilities require high availability to provide round-the-clock care for patients. The public safety industry include agencies that provide security and services to a community, state, or nation. The retail industry depends on efficient supply chains and the delivery of products to customers. Now, what are the threats to availability? So there are different threats that affect the availability of services of an organization or um, an office or a company. All right. So the threats can range from failure of a mission critical application to serve to severe storms such as a hurricane or a tornado. So, threats can also include catastrophic events such as a terrorist attack, building bombing, or building fires. So, designing a high availability system um, incorporates three major principles to achieve the goal of uninterrupted access to data and services, and which is these principles include the elimination or the reduction of single points of failure, system resilience, and fault tolerance. So let's look at measures to improve availability. Asset management. Asset management. So an organization needs to know what hardware and software assets they have in order to protect them. So asset management includes a complete inventory of hardware and software. So this means that the organization needs to know all the companies that can be subject to security risk. So this could include every hardware system, every operating system, every hardware network device, every network device operating system, every software application, every firmware, every language runtime environment, and all individual libraries. So many organizations may choose an automated solution to keep track of access. So we have access classification. So access classification assigns all resources of an organization into a group based or on common characteristics. So an organization should apply an access classification system to documentation, data records, data files, and disk. So asset standardization. So as part of an IT asset management system, an organization specifies the acceptable IT assets that meets its objective. Then there's threat identification. So the United States Computer Emergency Readiness Team, which is the US CERT, and the US CVE, Department of Homeland Security, sponsor the US Department of Homeland Security sponsor a dictionary to common vulnerabilities and exposure. So the CVE identification contains a standard identifier number which with a brief description and references to related vulnerability reports and advisories. Then risk analysis. So risk analysis is a process of analyzing the danger posed by natural and human caused events to the assets of an organization. All right, then mitigation naturally involves reducing the severity of the loss or likelihood of the loss from occurring. So many technical mitigates uh, controls mitigates risk, including authentication systems, file permissions, and firewalls. Now, defense in depth. So, defense in depth will not provide an impenetrable cyber shield, but it will help an organization minimize risk by keeping it one step ahead of cyber criminals to uh, make sure data information remains available, and an organization must create different layers of protection. So a layered approach provides the most comprehensive um, protection. So if cyber criminals penetrate one layer, they still have to contend with several more layers, with each layer being more complicated than the previous one. So layering is creating a barrier of multiple defenses that coordinate together to prevent attacks. Then limiting access to data and information reduces the possibility of a threat. Diversity. So diversity now refers to changing the controls and procedures at different layers. So breaching one layer of security does not compromise the whole system. So an organization may use different encryption algorithms or authentication systems to protect data in different states. So another thing is obscuring information. So obscuring information can also protect data and information. So an organization should not reveal any information that cyber criminals can use to figure out what version of the operating system a server is running or the type of equipment it uses, because that information can educate the threat actor on a method he can use to penetrate the system. Then complexity does not necessarily guarantee security. So if the process or technology are too complex, misconfigurations or failure to comply can result. So simplicity can actually improve availability. Then redundancy. So a single point of failure must be identified and addressed. A single point of failure can be a specific piece of hardware, a process, a specific piece of data, or even an essential utility. Remember that a chain is only as strong as its weakest joints. So single points of failure are the weak links in the chain that can cause disruption of the organization's operations. So generally, the solution to a single point of failure is to modify the critical operation so that it does not rely on a single element. So the organization must can also build redundant components into the critical operation to take over the process. That's if any of those points fails. So N plus 1 redundancy ensures system availability in the event of a component failure. So components needs to have at least one backup component, right? For example, every car has a spare tire, right? A redundant array of independent disk, which is RAID, combines multiple physical hard drive into a single logical unit to provide data redundancy and improve performance. So RAID takes data that is normally stored on a single disk and spread it out among several drives. So if a single disk is lost, the user can recover data from the other disk where the data also resides. So RAID can also increase speed of data recovery. Remember, sometimes when you want to download some files, large files, very large files online, you see uh, download mirror. You see a normal download link. You see download mirror 1, download mirror 0, download mirror 4. So that's an example of RAID technology being used there. So using multiple drives makes retrieving request data faster. So instead of relying on just one disk to do the work. So a RAID solution can be either hardware based or software based. The following terms describe how RAID stores data on the various disks: is parity, okay, which is detects data error; stripping or striping, which writes data across multiple drives; mirroring, stores multiple data or stores duplicate data on a second drive. Spanning tree. So spanning tree is a network protocol that provides for redundancy. So the basic function of um, spanning tree is to, which is the STP, is to prevent loops on a network when switches interconnect via multiple paths. So STP ensures that redundant physical links are loop free. So it ensures that there is only one logical path between all destinations on the network. So STP intentionally blocks the redundant path that could cause a loop. So a default gateway is a typical or is typically the router that provides device access to what the rest of the network or to the internet. So if there is only one router serving as a default gateway, it is a single point of failure. So router redundancy involves choosing to install an additional standby router. So the ability of a network to dynamically what recover from the failure of a router acting as a default gateway is known as first hop redundancy. So whereby if router 1 does not work, it is automatically hopped to a different router. Router redundancy options. So router redundancy options are available for router redundancy. Available for router redundancy would include hot standby router protocol. Okay, this one provides high network availability by providing first hop routing redundancy. Virtual router redundancy protocol. A virtual router redundancy protocol router runs the VRRP protocol in conjunction with one or more other routers attached to a local area network. So in a VRRP configuration, the elected router is the virtual router master. So and the other routers act as backups. So in case the virtual router master fails, the other the message is automatically hopped to the next router. So gateway load balancing protocol GLBP protects data traffic from a failed router or circuits like HSRP and VRRP. So while also allowing load balancing, also called load sharing, between a group of redundant routers. Location redundancy. So an organization may need to consider location redundancy depending on its needs. So the following outlines three formats of location redundancy. Synchronous or asynchronous synchronizes both locations in real time, requires high bandwidth allocation, must be close together to reduce latency. Asynchronous replication, so not synchronized in real time but close to it, requires less bandwidth and sites can be further apart because latency is less of an issue. Point in time replication, so update and backup data location periodically and is the most bandwidth conservative option because it does not require a constant connection. System resilience. So resiliency defines the method and configurations used to make a system or network tolerant of failure. So routing protocols provide resiliency. Resiliency design is more than just adding redundancy. Resiliency is critical to understand the business needs of the organization and then incorporate redundancy to create a resilient network. Now, incident response phases. So, incident response defines the procedures that an organization follows after an event occurs outside the normal range. So, when an incident occurs, the organization must know how to respond. Organizations need to develop an incident response plan and put together a computer security incident response team, which is CSIRT, to manage the response. So, incident response has uh, or consists of four phases: preparation, detection and analysis, containment and eradication, and recovery, then post incident follow up and documentation, obviously. So, there are main technologies that are used to implement an incident response. We have the NAC, the Network Admission Control. So this one allows access for authorized users with compliance systems. So a compliance system meets all of the policy requirements of the organization. Then there's intrusion detection system, so monitor the traffic on the network. Then there's intrusion prevention system, operates in inline mode. It can detect and immediately address a network problem. NetFlow and IPFX. NetFlow is a Cisco iOS technology that provides statistics on packets flowing through a Cisco router or multi-layer switch. So the Internet Engineering Task Force (IETF) use Cisco's NetFlow version 9 as the basis for IP flow information exports. Then advanced threat intelligence can help organizations detect attacks during one of the stages of the cyber attack, and sometimes before with the what right information. Disaster recovery. There are different types of disasters. All right, so it is critical to keep an organization functioning when a disaster occurs. So a disaster includes any natural or human caused event that damages assets or property and impairs the ability of an organization to continue operating. So there are natural disasters and there are human caused disasters. So natural disasters are geological disasters, which could be earthquakes, landslides, volcanic eruptions, or tsunamis. So meteorological disasters could be a hurricane, tornado, right? There's health disaster, all right, which is, could be a world pandemic. Then there's miscellaneous disaster, which could be fires, wood, right, wildfires, all right, avalanches, and the rest. Then human caused disasters could be labor events, right, slow down, social political events, right, which is vandalism, protests, and the rest. Material events, which could be hazardous spills and fires, and utilities disruptions, which could be power failure, communication outages, fuel shortages, and radioactive fallout. Need for business continuity. So business continuity is one of the most important concepts in computer security. So even though companies do whatever they can to prevent disaster and loss of data, it is impossible to predict every scenario. So it is important for companies to have plans in place that ensures business continuity regardless of what may occur. So business continuity considerations con- control business continuity controls are more than just backing up data and providing redundant hardware. So business continuity considerations should include documenting configurations, establishing alternate communication channels, providing power, identifying all dependencies of for applications and processes, understanding how to carry out automated tasks manually. So there are some business continuity best practices. For example, write a policy that provides guidance to develop the business continuity plan and assign roles to carry out the tasks. Identify critical systems and processes. All right. Identify vulnerabilities, threats, and calculate risk. Identify and implement controls and countermeasures. Devise methods to bring back critical systems quickly. Write procedures to keep the organization functioning when in a chaotic state. Then test the plan, update the plan regularly. All right, so we've looked at a few things in this chapter. We explained the 5 9 concepts, which means that when your company is available 99.999 percent of a year, it means that you have a downtime of just 5 minutes and 26 seconds. And we also discussed the various approaches that organizations take to ensure system availability. We also discussed how organization can respond to incidents, all right, and some disaster recovery uh, measures.